So when you drive over a curve, when you're at the curve, you will tend to fall outward like this. If your speed is higher, then this will be case. If your speed is mild, then it will be this. If your speed is very low, then this will be your case. So based on the speed also. Okay, now we were going in details. So when you are at the curve, say you are here. Oh, my cars, my cursor got lost. So when you are, oh, what is not working? Yes, at the curve, your velocity is tangential. Tangential. So we are now writing Vt. T means tangential. Now what is tangent? Say if there is a curve here, tangent means like if a line that is just touching a point, this is tangent. What is tangent? It will pass only a single point. It cannot cross 2 points, single point. If it just passes through a single point, then that will be a tangent. And that will, single point, that means if it touches 2 points, then that means it is a crossing. So like here, if I touch 2 points, one point is here, other point is there, it is not a tangent, it will be a crossing line. Tangent is just touch the one point, that is called a tangent. So the velocity will be along the tangential direction, that is your velocity. Good. Now you know that velocity is a vector. That is something else to understand. Velocity is a vector. What does vector means? It has a direction. Direction is important. We cannot neglect direction. Okay, so it has a velocity that is tangential, and hopefully you understood what is velocity. Your speed, simply your speed. You might have a acceleration. That means you are increasing speed in curve. Although it is not common, but you might have acceleration. And acceleration will have two components. One is this way. Whatever your velocity, your change in the magnitude of the velocity, so that is called a t. What is t? Tangential. So whatever we are talking, t means tangential. You say your velocity is who knows 30 mile per hour, and your speed is changing every hour, say 10. That means next hour it will be 40 mile per hour in next hour. That means you have a acceleration. This change in speed over time is epsilon t. Change in speed over time is epsilon t. I know that you know this term. In last few classes, whatever you saw your v, whatever your t, this is actually that. So here v is actually vt, a is actually at. There's nothing new in these two terms. These two terms, whatever you studied, the general definition is the same thing. Now something new is coming. Now what is new? So here it is tangential like this. Now when your bike will come here, or when you'll come here, what will be your change in, what will be your direction? Your direction will be this way. That way will be your vt, that way will be your at. Now yeah, I think that this, you will agree with me that when you will be there, your velocity will be tangential. Velocity is always tangential. It has no other direction, because when you will head this way, your head will be this way and your speed will be that way. So continuously you will change your direction. So now when you are here, your velocity was this way, acceleration was also this way, at was this way. But here versus here, every time your direction is changing. Now question is how? Yeah, you can answer that when you are steering your car or you are steering your bike, you are changing it. So what is happening? You are continuously applying a force this way, here, this way. here this way. You are continuously applying some force to change the direction that way, which you do not feel it. Now, so in this way, you have no speed. In this way, you have no speed. It is just the change in direction. So, as something is there, so there is an acceleration in that way. That is called AN, normal acceleration, normal towards center. So, N means normal and direction is toward the center, toward the center. So, this is important to remember that it is normal, that means perpendicular. Normal means perpendicular. Okay, so if I show you, this angle is 90 degree. This angle is 90 degree. This angle is 90 degree. So this is how it is called normal. And towards center, I can write towards center. So you need to apply some force to change the direction, and there, and then what is happening? Happening is that this way you are not moving, so there is no normal velocity. There is no normal velocity. This Vn, forget it. There is no normal velocity because your car, your bike will not go that way, will not go outside road. Your bike will be on the road. So velocity is tangential. But to change the velocity, you need to apply some acceleration that way. Now why? Because acceleration is the change in velocity. Your velocity might be 70 mile per hour, but when you are changing the direction, so if you change the direction, that is also a acceleration, because change in velocity is acceleration, not only magnitude but also direction. So there is something you are applying this acceleration this way, that is called normal acceleration. Now how to calculate it? Easily, AT you know from your speed data. Say last hour is your speed was 60 mile per hour. This hour your speed is 70 mile per hour. So your change in speed is 10 and divided by 1 hour. So that is your AT, acceleration. Very simple to calculate AT. How to calculate AM? Not so difficult. In your handout, I explained the theory. Here I am not going to the theory. Very shortcut. Just memorize the equation. How to find? An is Vt square divided by rho. What is rho? Rho is the radius. Rho is the radius. Sometimes we call instantaneous radius. Instantaneous radius. Why instantaneous radius? Instantaneous radius. Now why? Because my curve is changing. A curve is not a circular path. My okay, I will in the next figure I will take the clean part only, because in this slide there are a lot of things. In the next slide I will go clean only my whatever I need. So I am going to next slide. Make sure that you wrote it down. If you did not, let me give you one or few more seconds. By this time I'm telling you that instantaneous radius, that means radius at that point. Okay, now why? So there's a road, very small, then curve is increasing, suddenly curve decreasing, again going this way. So say if I go here, what is my radius of this portion? Very high, very high. My radius is this, very high radius. When I am here, what is my radius? If I think this is my circular portion, this is my circular portion, so radius will be roughly here. So radius changing. What is my radius here? So that will be say this way, somewhere here. So you can see every moment your radius is changing. So we should be considered about at that point. So in technical term is instantaneous radius at that moment. Now somebody may ask me, if it is circular, it is not changing every time here versus here, every time is same, every time is same, then what? Yeah, then your life is simple, only one radius, done. You can write r. So your normal acceleration, you can write vt square divided by, I wrote in your handout maybe uppercase r, not lowercase. Whatever case doesn't matter. As long as you understand, you can use this symbol. Who knows a tree? That is also okay. You can use this symbol a fish. That is also okay. Symbol doesn't matter. You can use your own symbol as long as you understand. But better to use a symbol that everybody knows. If I say r, anybody will know. By hearing r, everybody will first guess maybe it is radius. So that is why it is better to use a symbol that everybody uh, can understand easily. Okay, so now every moment you have a vt and at. At is tangential, and there is a acceleration which is called normal, and normal is vt square divided by rho. Rho means any radius, we do not know. Other question, if it is not circular, then how to find rho? It's a very big question, and answer is very simple. Yeah, if it is not a circle, that means it has a equation. This curve has a equation. If you know the equation, say it is y, any function, then we can find the radius of this at any point. How? I did not memorize the equation, it is just a calculus. This equation, 1 plus dy by dx. Now what is y, what is x? Other question, okay, I will come here. Say you can assume a xy, this is x, this is y. Say this is your function y. That means you are setting this curve in terms of an equation. Then you can do the differentiation with respect to x, not t. If you differentiate y with respect to time, it will be velocity. It's not with respect to time, with respect to your horizontal axis. That means simply you are trying to locate this curve. Okay, so if I go to your handout, so no need to get surprised, just use this equation. Find dy by dx, take a square. So you will find this and insert the value here. Then take a square, then add other power. Here you will do a second derivative and take the sign, value only, not the sign. It means this, take the value only, not the sign. Then you will get a radius. Is it difficult? No way. Okay, so hopefully at least you learn how to, calculate this normal. Okay, so if I draw a new one, say this is your curve. At any point you have vt. See, I am writing again and again. The reason is so that it goes to your memory, and if you write with me, automatically you will memorize or understand about 70-80%. The next 20-30% is just reading the books, learn more theory or practice example. So vt tangential, at tangential. Which way is your normal acceleration? Towards center. Do not draw this way. Do not draw that way. No. Draw this way. Towards center is your an. How to find it? Whatever your velocity, tangential velocity divided by rho. There is no Vn. There is no Vn. Forget this. There is no velocity in this way. Why n? Just to change the direction of the velocity. Now all the theory is done. You know what is tangential. So this is tangential and this part is normal. That is the coordinate system. Second thing, if I say what is the combined velocity, how to find it? This is 90 degree. Combined velocity is Vt square Vn square. As Vn is 0, so your V and Vt same thing. Velocity is only one. There is no two parts. Acceleration, yes. So acceleration will be summation of both. So your combined velocity will be summation of both. Oh no, sorry, not summation of both. The combined effect, the effect of both, using this Pythagoras or parallelogram rule. How to find rho? Equation. Equation. If it is circular, simple. This is R. This is R. Now everything should be very clear. Something else I was thinking. Yes, I got it now. Okay, in this figure I will do it. Actually, this topic is not for this chapter, it's for next chapter, but I am finishing it at the same time. What is that? Force. What is force? Force equals mass time acceleration. I believe that you know it. Force equals mass time acceleration. If you do not know it, for now just accept it. That force equals mass time acceleration. Whatever I am telling, believe me now. And in fact, this is the second law of Newton. So it has no logic. You do not know it. You know it. Maybe you forgot. So now remember. But this is not our topic. This topic is in next chapter, chapter 3. But we are doing it in advance as this topic came. Okay, so mass, force, time, acceleration. So there is acceleration in this direction, normal direction. So there must be some force then. So what is that force? Force will be m, mass of this, times an. That means m vt square divided by rho. It is along the normal direction. Forget about this direction. We do not need it now. We are talking about normal direction. So whatever the force in normal direction that we apply to change our direction of the velocity is called centripetal. So memorize this term, centripetal, P-E-T-A-L. So centripetal force, the force that we apply or we needed to apply to change the direction in a car path. It is called centripetal. This force is actually we apply. We apply it. If we do not apply, then our car mm, will not turn. It would be a straight line and go out of the field, and then sometimes later a police will come. So continuously we are turning our steering wheel, steering, but we cannot see that. By turning, we are actually applying the centripetal force. We are applying this centripetal force which you do not see, but we apply. Other question at the beginning I told that when you go to car, you intend or you feel that you are being thrown outward. Why? Other question. So that question will answer here. But before answering, say, give me an example. You are not driving. You are riding in a bus, and you are not sitting. You are standing, because there is no seat. So you are standing in a bus. Suddenly the bus applies some brake. What will happen to you? For sure, you will be thrown towards the front of the bus if brake applies. Now question is why? Okay, we'll answer it next. Say the bus is standing. Suddenly the bus started to move very fast. Then you will be fallen behind. Why? That why, and here why you will be thrown outside, same thing. So okay, let me take a new case, new case. So what is that? Say curve, you are here you are standing here, somebody is pulling you this way. To change the direction from this way to this way, somebody is pulling you, that is mvt square by r. Now v is always tangential. Do I need to write it t? Up to you. If you write this, same thing, doesn't matter, because vt is always same. There is no vn, but sometimes I write t just to differentiate or make you feel better. Okay, so somebody is pulling your leg. Somebody is pulling your leg, so your head will obviously tend. It's not like tend to go that way. Same thing in your bus. When you are, so bus is here, you are standing here, bus is going that way. Suddenly the bus apply brake. If the bus apply brake, now what does brake means? Brake means actually applying opposite force. This engine in here, bus is applying a force opposite way, so that this force cancel each other. That is the brake meaning. So bus is going this way, it is applying a force that way. Then what is happening? Your leg is going this way, but your head is trying to fall that way. So opposite effect in your body. Somebody is pulling your leg. If somebody pulls your leg towards north, you will tend to fall towards south. So this way. So this force is called centripetal. Centripetal. This force, what you feel, again, this is not a real force. It is a feeling. You feel it. It is called centrifugal. Centrifugal force. So mathematically, centripetal and centrifugal force are equal. So we use the same equation to find centrifugal force. But again, this is conceptually not centrifugal, but mathematically they are equal. So that is the meaning. So again, we will use this equation, but sometimes remember, this is actually not. It is actually a feeling. You feel that you are being thrown outside. Why? Somebody is pulling your leg. Okay, so hopefully you understood the concept. Now, if I explain more theory, I know that you do not like theory, but again, theory is sometimes good to understand. Not if you understand, you will feel better. Okay, so there is a stone. You tied it at the end of a rope. So you are here, and you are. I know how to express this. A stone is here. Say you are rotating, or how, what is the best word, whatever. So there is a stone at the end of a rope, and you are moving it in a circular vertical. It is vertical way. Vertical. I know that this question is somewhere in your book. Maybe chapter 3. This topic is in chapter 3, is in chapter 4, is in chapter 6. So the same topic I discussed, repeated many times. The reason is so that it goes to your brain, or you refresh it, because it's very important and very conceptual. And in FE exam, I guess there will be a question from here. I cannot guarantee, but I can guess. It is very important topic. Here, the question is, what will be your tension? Tension in the string here. Tension in the string. When do you need higher amount of force? When do you need lower amount of force? That's that kind of question. So when you're particularly at the bottom, it has a mass. Oh no, this question is chapter actually 4. It is in energy. Okay, so we will not start this topic in this chapter. We are not talking. We did not cover that energy or force. It is in next chapter. So you are good. We are not going there. So we coming back to our original discussion, this coordinate system only. Maybe I confused you, but again forget those part. That was the next chapter, not in this chapter. But here I can see normal force ma mv t square by r. V means tangential velocity, so if I write t or no, it is t. One example, a car is going in a curved path. After traveling 200 meter, it got a speed of 20 and increase in the speed. So increase in, I'm writing in the, yes. So it has a speed say 20 and this speed is increasing at a rate of 2 meter per second square. That means, okay, before starting, what is 20? It is your V or VT. Okay, write it down. If I make, that we make it. Okay, so what is this V? V or VT, both are same. That is your 20 meter per second. What is that increase in speed? Increase in speed. This is your change in speed. That means this change in this speed. So that is AT. Do not consider that is normal. This is the change in speed only. So AT is 2 meter per second square. And how much did you travel? 200 meter. This is straight path. This portion, it is not the so if it is car path like this, there will be a normal acceleration this way. It is not that radius. We need to find this radius. X is, that is the equation of this path. Now in normal road, we can find equation very roughly, not exactly, because our road doesn't follow an equation exactly. But in small segment, we can easily easily make or derive our equation. What is the question? Magnitude of the acceleration at this moment. What is the magnitude of the acceleration? You can see they did not tell what kind of acceleration. They gave us a acceleration. Then why they are asking? The reason is they gave us tangential. They do not tell it what is it is tangential or no. You have to understand. They told us that your increase in speed, your speed is increasing. That means it is changing. So it is tangential. And find the acceleration. That means the combined. Something they will not tell you clearly, but you have to understand. Okay, so what is combined acceleration? Is this this part is given 2 meter per second square, very easy. This part how to calculate? Vt square by rho. How to calculate rho? To calculate rho, I need dy by dx. How to find it? 0.12x. That means 0.2x. That is dy by dx. I also need a double double calculus. How? I will do this one more. So 0.2. Why 0.2? Because there is a power 1 and the power will decrease by 1. Oh. So there is a power 1. If I bring the power 1 down and the power will go down by 1, this part is actually 0, also 1, so 0.2. Okay, so I can find my rho. How to find my rho? I forgot the equation, but I can remember something. Oh, there's a x here. What is x? X was given, if you can remember in your problem, 100 meter something, 200 millimeter. That is your x, because we want the acceleration at that point. Okay, so what I will do, I will go there. So insert here 200. So you will get it 40, I think 40. Okay, then what is my equation? I think I can memorize this. Try to So this is dy by dx square, entire is 3/2, second is second derivative. What is, okay, I will not solve it now, it is already solved in your book. I will go there, but I gave you the concept what to do. This is given, this is given, equation given, do a single derivative, insert the value of 200, the x, find the value, one value is done. Take a second derivative, whatever you did the first, do that one more time, and you got a constant number, so no need to insert. Use it in the equation to find your rho. Once you find your rho, apply calculate an as bt square by rho. Once you find an, insert it there, calculate the acceleration. That is the concept. Now, if it is a circular path, you do not need to find. If it is a circular path, you do not need to do all this. In circular path, this portion is, you do not need it for circular, because in that case you will replace this by r, radius. But now you need to do it because your road is a curve. Okay, so if I go to your handout, I'm not doing the calculation, I just gave you the concept. So you can see what they did it. First they wrote the equation, they wrote what is given, they wrote the equation, then equation to the finding the rho, and to find rho they are doing the differentiation. They are find the differentiation first time, second time, then find the value at x 200 meter, because at that point we need the acceleration. Then they calculated rho, but mostly your rho will be, for our civil engineering, mainly rho is radius. We try to make a circular segment for a horizontal curve. You will see in highway design, or maybe you might see it in surveying class, that the geometry of the horizontal curve is a circular. That is the ideal. So if you make it circular, that radius of the curve is actually this. So if you make your road circular, your life will be very easy. Find normal acceleration and then find the combined. So that's the way to find combined acceleration. Once you find combined acceleration, I can add what is the centripetal force. I can ask what is the centrifugal force. Same thing, mv square by r. I can extend it. Okay, let me, okay, now let me stop my video here.